Okay, hey guys, welcome. Um, my name is Merdan. Carlo gave us already an introduction about what we will be doing today and tomorrow. This bootcamp is basically consists of like two parts. For today, we will be going over the technical stuff without scaring everyone too much. So we will cover topics like Solana basics, Solana 101, basically everything to get you started to build for the Colosseum hackathon. And then tomorrow, everything will be about Colosseum itself. So what you need for your submission, how it works, how you can approach the hackathon to increase your chances of winning. I personally was lucky enough to win once globally and then also win locally every time. So hopefully I'll help you to understand how to approach this. And yeah, and and for today, we will go over the technicals, as I said. We will start with a high-level overview of Solana and what Solana is. And then, as Carlos said, we have Jonas here from Solana Foundation, who will also give a workshop, and Thilo from Light Protocol, and Sati as well, who is a AI expert, who will help you and hopefully show you some interesting resources. So yeah, and to kind of, before we start, to set the expectations for today, I know that a lot of you are non-technical, and maybe this is the first time you're touching Solana or you're building on Solana. Definitely don't get scared. Like when I first participated at Colosseum, I thought like there's this misconception that you think you need to build a Solana program and you need Rust. But that's not the case. Of course, it helps a lot to know the basics, but, and this is why we are doing this today, but there are so many powerful APIs, there's so many powerful TypeScript SDKs around stablecoins, around everything really, where you don't need to build out everything from scratch. There are so many great boilerplates. All of those things we will show today and hopefully help you with your Colosseum submission. Okay. Okay, so first let's start out with a general question, like very high level. What is Solana? We all know Solana is a high-level, high-performance blockchain, or in other words, it's a distributed ledger network. And you can think of this as a global network of computers and that work together to process transactions and maintain a shared record of activity and run applications. This is the interesting part for us. Developers, like the more useful mental model is to not just think of this as transactions, but a place where you can build your application on. So not just a place where tokens move around. So it's a system where apps, assets, and money can all interact in one shared environment. And that is the main framing that I want you to have for the rest of the day. So Solana is not just for transfers. It is a blockchain designed to support real applications. All right, so the next question is, why was Solana built this way? As you know, it's different from other blockchains like Ethereum and Bitcoin. And the best way to understand this is to start with the bottleneck, which sequential execution is a bottleneck that Ethereum, for example, has. And in many blockchain systems, transactions are ordered and then executed one by one. That works, but limits throughput. And because the system has to wait for ordering before it can move forward. And Solana's key insight here is that you can order everything first and then execute the non-conflicting transactions in parallel. And that is where proof of history, which you might have heard of, comes in, which we will talk about later as well. And the easiest way to think about this proof of history is as a cryptographic clock, a verifiable sequence of hashes that proves time and ordering. And the key point here is not the exact mechanics of every hash, but the bigger idea is that Solana separates ordering from execution, and that opens the door to parallelism, which makes Solana so fast, and which is a bottleneck on Ethereum. And, but ordering first is only one part of the story. If you want to execute transactions in parallel, the runtime also needs to know which transactions conflict and which do not. And that is why transactions declare accounts. They will touch up front. And if two transactions touch different accounts, they can run at the same time. And if they touch the same state in a conflicting way, they have to be scheduled separately. And this is also why Solana's architecture looks different and everything is built around accounts. You'll hear this a lot on Solana, that everything is an account, which we will dive deeper in a bit as well. And another important thing, programs are stateless, which means code is separated from mutable data. So you order first, and then once you do that, you need a more explicit architecture for parallel execution. And basically what this enables is you have higher throughput, as I said. Solana has really high throughput, much lower transaction costs. And those are just not just technical benchmarks, they can change what kind of applications become practical and viable on Solana. So real-time applications become more feasible, composability at scale becomes more feasible. So the point is, the chain is not just fast, but the point is that the architecture makes certain classes of applications much more realistic. Yeah, and, as you might know, like there are so many protocols on Solana, but if you like combine throughput and low latency and low cost transactions, you start unlocking these different verticals like payments, DeFi, consumer apps, games. Like imagine building an app and having to wait like for 10 minutes for your transactions to land and confirm, which that's not the case with Solana. So it unlocks a lot of useful things. And yeah, so the big message here is the architecture is not interesting for its own sake, but it's interesting because it unlocks real application categories. Okay, so this was just like the high level explanation or intro to Solana to give you a general picture of how things look and how they differ from other chains. And for this next workshop, I think Jonas is going to show us now a bit more the current state of Solana and some useful resources that you can look into. And then after that, we will dig deeper into the fundamentals, so the account model, programs, and basically everything that you will need to hopefully understand Solana better and use AI to ship your apps faster. So Jonas, if you can come up. das war jetzt mal.
Machen wir direkt weiter oder ist das? Ja, ich würde schon sagen, war schneller als gedacht jetzt.
Ich glaube, soll ich das Bild dir dann schicken? Weil ich habe jetzt
Who is ready for some Solana knowledge? So should I get started? Yeah, wait a second. I'm waiting another second. So what you can already do is scan this QR code. Okay. So yeah, welcome everybody. Today I'm going to talk to you about upcoming tools on Solana that are currently hot in the ecosystem and the state of Solana, how it will evolve over the next year. And in the beginning, I will also explain you how Solana actually works. So what is Solana? Who of you knows what Solana is? Oh, everybody. Yeah, here. What do you think?
Blockchain. It uses Rust. It is really fast, cheap, reliable. So that's basically what I know about Solana, and I want to know more. That's why I'm here.
Yeah, exactly. So yeah, it's a high-performance network written in Rust. And if you're a developer, you can basically think of it just as a big decentralized database where you can deploy your Rust programs and they run globally around the world forever. Who am I? I'm Jonas Hahn. I was a game developer for over 10 years at InnoGames, and I also worked for VUGA here in Berlin. And yeah, I built tools, I worked on verifiable builds, program metadata, and currently I'm also maintaining the Solana Explorer. So if you need any changes to the Explorer, let me know after the talk. Yeah, Rust on Solana. So the cool thing about Solana, I think, is that you can just take any Rust program and you compile it to eBPF via LLVM, and then you deploy it to Solana, and it will just be there forever, and everyone in the world can call your program. And you can do a lot of things with that. So the goal of Solana is actually to be one network where you can trade every asset in the world and every market on one network. So to achieve this, what we will do today is, first of all, we're going to play a little game that uses Solana. Then I'm going to explain you how Solana works. Then we go through all the different tools that are currently hot on Solana. And then I will tell you about the future of Solana and how it will develop in the next year. That's basically the timeline that Solana thinks of, like what happens in the next 6 months. So let's play this little game here. This is Solana 2048. And if you scan this, you can also play it on your phone. And yeah, I think it's good if we try out this game because I'm gonna reference it in the talk a few times later to explain you how transactions actually work on Solana. So a few people are still scanning. Okay, I think everyone's scanned. So now I'm gonna show you what this actually does. So you might know this game already, so you can move tiles around and stuff. And the interesting part about this game is that actually every move in this game is a transaction on the Solana blockchain. So here you can see that we are currently actually having a block time of under 400 milliseconds. So you get your transaction confirmed in a third of a second at the moment. And yeah, there's a few more things that this game has. So whenever you start a game, a little bit of soul goes into a treasury, and every night the best players actually get the rewards paid out. So here we can see currently the weekly record is 4,700 points. So maybe we find a little praise if someone like until the end of today gets the high score of the week. Yeah, so this is just to show you how fast the transactions on Solana are. And I'm gonna explain you in a bit how Solana, I get addicted to this game actually. How Solana actually achieves this, that you can confirm transactions in, currently it's actually 300 milliseconds. That's crazy. I think a few months ago it was still 400. So, yeah, how does Solana work? So Solana is basically just a spicy distributed database. And time is divided into 400 milliseconds blocks. And you have a leader schedule which changes every 4 slots. So you have one leader that actually has like 1.6 seconds to decide what's going to happen on Solana. And these leaders, they ingest the transaction. So you basically send your transaction directly to this leader, and then the leader performs these transactions and sends it to all the 1,000 different validators. And then the validators, they replay these transactions, and then they vote on each other, between each other, and at some point you have 66% of stake voted to it, and then your transaction actually gets written into this cool distributed database. This is the current state of the Solana validator network. You can see all the validators are distributed around the world. There's a bunch of in Europe. I think the fastest ones are in Amsterdam because the fiber cables actually go from there to New York. Then you have a bunch of in New York, which are really fast. Then you have a bunch of in Japan. And apparently we have some in South Africa as well, and a few in South America. And there's also one in Australia. So yeah, here you can see that this definitely is a distributed system. And then what happens if you do a transaction? So in the game that we played before, what you do is you swipe to the left or you swipe to the right, and this is happening via a transaction. So a transaction invokes a program. So I deployed a program which has the logic for this game on chain. And then the programs are all written in Rust. So there's no domain-specific language like in some other blockchains. And then they are compiled to eBPF. Does anyone know what eBPF is actually? So it's basically a bytecode format. And then what the validators do is they have a just-in-time compiler. So they read this program that you deployed, they directly ingest it, and then they perform the actions that you do in this transaction. And to perform a transaction, you need to pay in Sol. So everything on Solana happens with the Sol token. If you want to allocate some data in this big database, you need to pay Sol for it. If you want to change data, you need to send a transaction and you need to pay Sol for it. So that's actually the use case why Sol exists. Then if you want to store something, you basically just store it in a simple key value store. So if you have a wallet, then your key would be your wallet address. And then whatever you want to save, you put into this value store. And on-chain programs can also own and modify accounts. So your wallet, for example, if you have a token, if you have some USDC, that would be an account on Solana. And sending and receiving transactions. So as I already said, like I want to move to the right now, right? So what does my client do? It creates a transaction and it sends it to the current leader. And the current leader gets these transactions via the Quick protocol. This is just a protocol how you send transactions like data over the internet. And you can either submit it to a JSON RPC node or you can directly send it to the current leader. So every one of these leaders, you can actually directly send your transactions there and they will put it into the blockchain. So basically you can interact with Solana without having any other infrastructure and it will work forever. This is how a transaction works like. So in our case, it would be, hey, I want to move to the right in this game. Then I put this into a transaction. I create a message out of it. Then I put a block hash in there. And then I just call send and confirm transaction. It goes to the blockchain and it will confirm. This is then how it ends up in my program. So I have the move right instruction. My program checks, hey, I want to move to the right. It reads the table from the game, so you have all the different tiles. It calculates, I want to move to the left, so it moves like all the tiles to the left. And then in the end of the transaction, it writes your data back into the account. So, and the client in this case would be your phone when you played the game. So you create this instruction with move right, you're sending to an RPC node, the RPC node sends it to a leader, the leader puts it into a block, then this block is sent to all the other validators, they vote on it, and then you get the new state back in the game and you can do the next thing. And all of this happens in just 300 milliseconds. Pretty crazy. So what is Solana used for? Of course, the main use case is trading and finance. So you can trade there, you can send money for almost free across borders. Then there's a thing called DePIN, so decentralized physical infrastructure. That's actually my favorite project on Solana is called Helium. And what they do is they pay people tokens so that they put hotspots into their houses. And then these hotspots provide internet to the people around it. So imagine you are traveling the world, but you don't have to always get a new SIM card everywhere, but you just always use the Helium network. So, and this is super cool because it's decentralized. These people just get paid in tokens. And then when you travel around, you can just use the hotspots that are already there. Then AI agents is the biggest thing right now. So you can have AI agents pay for things. Then games, like you saw, we played a game earlier. Like I'm a game developer. That's why I always make my examples into games. And then you can do it for whatever you can think of. So, starting with some things that are currently interesting on Solana and that maybe you want to build into your hackathons. So there's agentic payments protocols on Solana. So X402, who knows the error code, HTTP error code 404? What does it stand for? And what does 402 stand for? Exactly. So this is an error code that was always there in the HTTP specifications, actually. But in the last year, Base was the first one to adopt it. But what it means is that you get a 402 error now. And it means payment required. So it gives you back a JSON file, which tells you how much you need to pay to access this HTTP page. And then you basically, in the response, you get like a wallet address where you need to send money, how much money you need to send, and as soon as you send this, you are able to access this, this data on the internet. And this is, of course, really cool because it enables AI agents to pay for anything. So there's a bunch of people who already provide, like, for example, MCP servers that you can pay for in Solana. There is some examples how agents buy stuff on Amazon and Stripe using Solana. So this is a very hot topic. So it's a very good thing to build something in that direction for the hackathon, because it allows lots of possibilities. MPP is basically the new thing already. So X402 was like 3 months ago news, and MPP is the new thing, which is like built by Stripe and Tempo, and Solana already has support for it as well. So you have support for X402 and you have support for MPP, so you can just use both of them. Then there's a new tool which is built by the Solana Foundation as well. It's called Cora. I wonder if I can somehow do this full screen actually, but I don't know. A big problem on crypto was always that you need to pay for gas fees, right? And now with Cora, you can actually abstract this away. So you can do gasless transactions. Basically, you pay the fees for the users, and you have certain rules on when the users are allowed to do this. And what you can also use this for is for an X402 facilitator. Who still remembers what X402 stands for? Exactly, yeah, we talked about it like 5 minutes ago. So, but you can also use Cora to pay for agents, basically. And then agents could completely for free roam through the internet. And how a Cora works is basically you do a request to Cora, you get a payment instruction. So you send your transaction that you want to send gasless, you send it to Cora. Cora estimates how much it would cost. Then Cora returns you a payment instruction. You put this into your transaction as well, and then you send these both transactions out, and basically Cora takes some of your tokens to pay for your transaction fees, and then you can send a gasless transaction. It's a really cool tool. It's production ready, and you can build stuff with it right now if you want. Another really cool tool that came out, or I don't know if it's actually released yet, but it's already in production by some teams on Solana. It's called Keychain. And what it is, it's a unified interface for signing Solana transactions with multiple backend implementations. So at the moment, if you send a transaction, you probably always use your Phantom or Soulflare wallet, or you have a local key pair. What you can do now is you can use just an in-memory key pair, you can use a vault, you can privy, you can use turnkey, you can use AWS KMS, Fireblocks, the Google KMS, DFSN, Para, CDP, Crossmint. So all these different signing methods you can now have in one unified payment API. This is just, I don't know if you need it, but this tool exists and it's also production ready and really, really cool. Here's the link to it. I will probably have the slides up later, so you can just look it up in the slides. Then, who of you used JavaScript to interact with Solana before? Someone in the back? You probably used Web3.js, right?
No, for the last hackathon, they changed it, but forgot to update the README or whatever. When I tried to use this, it was throwing a lot of errors, so I had to upgrade to Git.
I see. Yeah, so there is a big change in Solana ongoing for the last few months, which is Web3.js is deprecated because it was slow and big and everything, and there was a new SDK implemented, which is called Kit. This is the new shiny JavaScript framework, but there was a bunch of problems with it because it wasn't really usable really well. So there was many attempts to try it, to fix it by the community called Gil, Kite, Mucho, then there was Framework Kit and so on. And now we have the proper way of fixing it, in my opinion, which is Kit plugins. And these Kit plugins are really, really nice. So you can see that you're basically working with it, same as in Web3.js. So you create a client, and then you do just client.send transactions. So this is what you should use going forward. Then there is a new testing tool, which is called Surfpool, which is really cool. So whenever you test something, you might have problems because you need mainnet data or devnet data. Surfpool allows you in your tests to clone on the fly every state on mainnet. So you can basically run your tests directly with mainnet data. Let's imagine you want to do some Jupyter swaps or something. You can simulate it locally and just run your tests locally with mainnet or devnet data. This is really, really cool. So you can, with this, you can copy mainnet state, you can time warp. So in your tests, you can like, imagine you have like something where you lock up something for a few days. You can easily test this by just changing the validator time as well. You also have faucets in here, so you can get USDC tokens or any token you need. And there's also a nice dashboard for it. Then there is a very cool new and shiny Solana framework which uses no STD and zero copy. Who of you knows what no STD and zero copy means? No one. That's good. So the first one is no STD. What this means that your programs are not using the standard Rust library anymore. This makes every program about 150 kilobytes smaller. So if you ever deployed an Anchor program, you knew it's quite expensive. If you use Quasar now, it doesn't use the Rust standard library anymore, and you save 150 kilobytes. So you can basically deploy a program for 0.02 sol instead of before like 1.5 sol. So this makes programs much more easy, cheaper to deploy. Second one is zero copy. So if you used Anchor before, you know maybe that all the accounts were Borsch serialized. Borsch is a serialization library, and now we can use zero copy, which says like all the accounts are not serialized anymore, but they are directly read and written to from memory. You don't necessarily need to understand this, but if you try out Quasar, it's good to know why it's so much faster and so much cheaper. Here's a direct comparison between Anchor and Quasar. You can see the program binary is like 97% smaller. It's mostly because we don't have to put in the whole Rust standard library. The deploy cost is 0.04 sol versus 1.4. So it's like 30x times cheaper. Then also the compute units, whenever you do a transaction, much cheaper. And the compile times are also faster. So if you want to try a new beta framework that came out like last week, this is a cool thing to experiment with. Or if you're just poor and don't want to pay so much sol to deploy a program, this is a perfect choice right now. Then Anchor has new versions. Anchor is a programming framework on Solana, which makes it much easier to write and deploy programs. And there's now a V1 coming out. And Anchor is now owned by the community. Before it was built by Armani from Backpack. And now it's owned by the community, and the releases are done by the Solana Foundation. So the new version actually changes how IDLs are uploaded. It's using the program metadata program now. And Anchor V1 also has a bunch of cool new features. For example, it makes it way easier to migrate accounts. So that was a thing that was very difficult before. And also it has like Solana 3.x support now. Then if you want to start a project, we have new templates that have been released. Maybe I can quickly show the page. So there's a bunch of templates here that you can use. And the easiest one is the Next.js Anchor template, which just creates you an Anchor program and an app. And it's a very good starting point for your application. So now we are coming a little bit to the state of what will change in Solana in the next year. I think it's very interesting to know what's going to happen with Solana in the future. You saw already we have like currently block times of 300 milliseconds, which of course is incredibly slow. It's like, and we need to improve this, of course. And there's a few ways on how you can do this. So there's a bunch of problems still on Solana. As you knew, we have like only one leader at any point, which creates the whole block. And to solve this, there is a proposal by ANSA, which is called multiple concurrent proposers. It's called Constellation, and the leader of ANSA actually traveled to the desert just to present us this new proposal, which is called Constellation. And how Solana will change, probably in the end of this year or early next year, is they will have a new system. You know that the system I explained to you earlier was already quite complicated. With Constellation, it will probably be even more complicated. But what it's trying to do is that instead of having one leader at a time, you will have multiple leaders at a time. And what this allows Solana to do is that this one leader can't just reorder transaction how he wants anymore, and he cannot censor transactions, but instead you're sending your transaction to multiple leaders and proposers, and then you have testers, and then you have a leader, and then it goes to the validators. But yeah, what you need to understand here is that what it fixes is that you don't have this monopoly of just one leader at a time anymore. So this is probably coming to Solana mainnet end of this year, maybe next year. There's also discussions about it, so this is actually a quite hot discussed topic at the moment. So if you're interested in solving hard problems, you can try to find a better solution that is simpler than this one. There's a bunch of people in the Solana ecosystem which would rather see FCFS. What do you think this stands for? It stands for first come, first serve. So what they want, like what these people think is that this is too complex. And if you look at the graph, you might agree already. So what a bunch of people in the Solana ecosystem want to have instead is first come, first serve. So the first transaction that arrives at the leader should immediately go into the block, instead of having like ordering rules and different attesters and proposers. So yeah, if you're interested in hot discussions, go on Twitter and see what Trent and Anatoly are talking about, and then you will also hear these discussions. I really also would like to have like a very simple approach, because for me it's just like harder to explain. Then another thing that's coming is Alpenglow. While MCP is replacing how blocks are proposed, Alpenglow is replacing the consensus algorithm. So, and if these two features go live, actually all the novelty that Solana had in the beginning, like proof of history and Turbine and so on, they will all be gone. And basically Solana will be a complete new network. So what they are trying to do is bring the block times down to 150 milliseconds. So in our game that we played earlier, we had like 300 milliseconds to do a transaction, and this will bring it down to 150 milliseconds. And how they achieve this, it's actually really, really interesting. It was like a bunch of researchers from the ETH Zurich, which complained about that the Solana consensus algorithm is bad. And then at some point they said, yeah, okay, then fix it. And now they are working for ANSA actually, and they are building the new consensus algorithm, which is really cool. And basically how it works is that it replaces the tower BPF and the proof of history combination, and they replace it by a system that directly creates a proof of the blocks, and then all the validators only vote once on it. It's a very interesting topic, so you should read on it if you're interested in that kind of stuff. Then, yeah, Solana is running a bunch of hackathons. Most of them are run by Colosseum, and there's many hundred millions of prizes that have gone out of these. And at the end, usually, if you're winning, you also get seed funding, and you can start your company, and you can join the ANSA Accelerator in New York, and then you have like a hardcore program for, I don't know if it's 6 weeks or 6 months, where you try to build out your company. So this is a really great opportunity. So good luck. There's tons of opportunities. Submit your projects to the hackathon. And I will be here around here if you have any questions, especially any technical questions about Solana. I love talking about that stuff. So yeah, thank you very much for listening, and see me later.
Now we do like 1.5 hours-ish until like 1:30 is lunch break. So feel free to work here also, feel free to grab some food.